NASA has just released the clearest images ever captured of 3I/Atlas, an interstellar comet that didn't form around our sun, and these images completely reshape what scientists thought they knew. You should continue watching because this rare visitor carries clues about how other star systems create their worlds, and tonight, we finally see those clues up close. In this video, we'll break down what NASA actually found, how scientists decoded it, and why these results matter. The most striking part of NASA's new release is how these images finally reveal the structure of 3I/Atlas. Instead of a fuzzy, distant blur, spacecraft orbiting Mars like MAVEN and the Mars Reconnaissance Orbiter captured crisp data showing the comet's distinct coma shape, asymmetric outgassing, and surprisingly active jets. These details weren't visible earlier because the comet was hidden behind the sun for weeks, making ground-based observations nearly impossible. Scientists immediately noticed that the comet's brightness was not evenly distributed, meaning it's shedding material in a pattern unlike most solar system comets. This uneven activity strongly hints at unusual composition, possibly ices or dust that formed in a colder, more distant region of another star system. That revelation alone is enough to excite researchers, because it suggests the comet may preserve materials never found on objects that formed near our sun. What makes these images even more important is timing. Because 3I/Atlas passed close to Mars during its outbound journey, NASA's instruments captured it from just the right angle to analyze its thermal behavior and measure how solar radiation affects it. That combination, high-resolution imaging plus temperature data, creates a rare scientific window. The big takeaway from this section: we're not just seeing a comet. We're seeing the fingerprints of a world built in another cosmic neighborhood. The new imagery didn't just produce pretty pictures, it provided scientific clues about the comet's birthplace. The unusual jet pattern, which we mentioned earlier, indicates the nucleus is rotating irregularly, something more common in objects that formed in dynamically unstable star systems. NASA's spectrometric data adds another layer. The light signature suggests a mix of volatiles that differ from typical Kuiper belt or Oort cloud objects. This difference is the strongest evidence that 3I/Atlas originated far beyond our solar system. Scientists compare these results with observations from previous interstellar visitors, like ʻOumuamua and Comet Borisov, and the differences are striking. Unlike ʻOumuamua, which showed no visible coma, 3I/Atlas is highly active, releasing material that reflects a chemical recipe unique to its home environment. And unlike Borisov, which behaved like a relatively normal comet, 3I/Atlas seems chemically richer and dynamically more unstable. That combination helps scientists refine models of how planetary systems form and evolve. Another major insight comes from tracking how the comet slowed and brightened as it approached the sun earlier this year. That behavior, confirmed through NASA's thermal data, suggests the surface layers contain fragile compounds that break apart quickly under heat, something that tells researchers about the star this comet originally orbited. The link to the next section is clear. If this comet is chemically and structurally different from anything found in our solar system, then the implications for future exploration are enormous. These new findings mark a major turning point because interstellar visitors are incredibly rare and every one carries physical samples from another planetary system. With 3I/Atlas, NASA can now compare foreign star system materials directly with what we find in our own cosmic backyard. That comparison helps scientists refine theories about how planets form, how water and organic molecules travel through space, and how common or uncommon Earth-like systems may be. This comet also becomes a blueprint for future missions. Space agencies now have real data about how an interstellar comet behaves when passing near a planet, how quickly its materials break down, and what kinds of instruments are needed to study such objects in detail. That information is crucial for designing future intercept missions like NASA's planned Comet Interceptor, which might one day fly directly beside a newly discovered interstellar visitor. Another important impact is digital. The new data helps improve algorithms used to detect objects entering the solar system. The earlier we detect interstellar bodies, the more time scientists have to position telescopes and eventually spacecraft to study them. In short, 3I/Atlas isn't just a comet. It's a real-world sample of another star's history, drifting past us for only a brief moment, and we're lucky NASA captured it in time. Thanks for watching. If you enjoyed exploring this rare interstellar visitor with us, don't forget to like, share, and subscribe. Your support helps us bring more deep space discoveries to life. See you in the next video.